All right, so let's identify some angle relationships today. This is target 1 of Unit 3. First thing we're going to talk about is the angle addition postulate. And you could read kind of through the definition here. But basically, what that angle addition postulate says is that this angle, which is RSP, if you add it to this angle, PST, it's going to equal the measurement of the entire angle, RST. So to solve for x here and find out the measurements of the two angles, x, WY, and WYZ, we're going to use angle addition postulate. So we're going to take this angle, 2x minus 9, and we're going to add it to this angle here, 3x plus 6. That should equal the entire angle, the whole thing, which is 72. And now we're just going to solve the equation. So we have 2x plus 3x is 5x. Negative 9 plus 6 is negative 3. That equals 72. 5x equals 75. And then x equals 15. So we have x, but what we want to find out is the measurement of w, or x, y, w. So x, y, w is the 2x minus 9. So if we plug in 15 to that, that's what we're going to have. And then 2 times 15 is 30. 30 minus 9 is 21. So it looks like that angle is going to be 21 degrees. That is XYW. We're going to do the same thing with the other angle, 3x plus 6. Plug in 15. 3 times 15 and then plus 6. Here you're going to get 45 plus 6. And then I believe you're going to get 51 degrees. 51 degrees is the angle measurement for ZYW. If you notice, 21 plus 51, they add up to 72. So here we have 72 degrees. They should add up to that. We're going to do the same thing here. Now the whole angle, QST, is 120 degrees. So again, we're going to add up the two angles. 3x plus 2x is going to give me 5x. Positive 1 and negative 6 gives me negative 5. So 5x minus 5 represents the sum of the two angles, QSR and RST. So that's going to equal 120, the whole thing. We solve for x and divide by 5, and x equals 25. And then we want to find the measurement of QSR. Well, QSR is the, I believe it's the 3x plus 1. So we have QSR. So we're going to plug in 25 for x right there. 3 times 25 is 75, and then plus the 1 is going to give us 76 degrees for angle QSR. We have a lot of definitions that we're going to cover this unit, and really a lot of these you just need to make sure you understand. If you don't, please ask me or your teacher in class. I'm going to talk about perpendicular bisectors just for a minute. This line here that we have the arrows on that I'm highlighting, that is a perpendicular bisector of segment AB. It's perpendicular because it intersects at a right angle, and it is bisecting because, as you can see, this segment here, AC, is equal to this segment here, BC, because of these little congruent segment indicators there. So we know the blue line that I've just highlighted is going to be a perpendicular bisector. Now, let's say I draw another line and I draw this line. Is that a perpendicular bisector of line AB? I would say it's perpendicular, but it's not bisecting. So it's only perpendicular to AB. Let's say I drew this line. It goes right through C. Right here. That line I just drew right through C. Is that bisecting AB, the whole thing, AB? Yeah, because these two pieces are congruent right here. However, it's not perpendicular. So there's two things we have to know for a perpendicular bisector. It's about where it intersects the segment and how it intersects the segment. It must intersect at 90 degrees, and it must intersect at the segment's endpoint or midpoint. Skew lines. Two lines are skew if they do not intersect and are not coplanar. We know if two lines do not intersect, usually they're parallel. Okay, so like if we focus on SP and WZ, those lines do not intersect, but they are on the same plane. They're on this plane on the outside right here. They do run parallel to each other. They're never going to intersect, but they're on the same plane. There are cases where you have lines that do not intersect but also are not in the same plane. And that would be an example of that would be PS and XQ. PS and XQ are never going to intersect, but they also never share, they don't share a plane, and those are called skew. So let's just focus on PS right now. What would be skew to PS? That would be XQ. I'm going to actually, the lines that are skew to PS, I'm going to have in green right here. So that's XQ. What else is skew to PS? RY. Also, we have skew to PS is WX and ZY. So all four of those lines in green that I've shaded in are all skew to PS. What would be parallel to PS? Well, that would be WZ, XY, and QR. Those are three lines that are parallel to PS. And then I want to focus on, well, what would be perpendicular to PS? So here's PS again. Perpendicular would be SR, SZ, PW, and QP. Those will all be perpendicular to PS. So anytime you have a cube and you have all those segments, the relationships among the segments are going to be perpendicular, parallel, or skew. Just keep in mind skew lines will never intersect and they do not share a plane. Parallel lines, we've already talked about those, though they never intersect, but they are coplanar. So they do share the same plane. Transversal line is a line that intersects two or more coplanar lines at different points. So this could be considered a transversal, the line I just drew. It intersects two or more lines at different points. Here's the different points that it intersects at. When we have two lines that are basically intersected by a transversal, we're going to have 8 different angles that are going to be formed. And there is a relationship that those 8 angles are going to have with each other. And we're going to talk about that in just a minute. First of all, we're going to talk about interior and exterior. What is an interior angle? Well, it's the angles that are on the inside of the two lines. Those are interior. These are interior. So all the angles I just circled are the interior angles. What are the exterior angles? That would be this, 1 and 2, 8 and 7, 1 and 2 here, 8 and 7 here. Those are the exterior angles. Now let's talk about alternate interior angles. So first, we already talked about interior. They're in between the two lines. But alternate means that they're on opposite sides of the transversal. So 4 and 6 are both inside the two lines, but they're on opposite sides of the transversal. So those will be called alternate interior angles. The same thing here with 3 and 5, alternate interior angles. We also have this angle here that I'm shaded in blue, and this angle here. That's another pair of alternate interior angles. So every time we have two lines in a transversal, we will have two pairs of those types of angles. Consecutive interior. So that's basically same side interior. So that would be this angle in blue and this angle. Those are consecutive interior. I usually refer to it as same side, but either way, it means the same thing. We also have another pair of consecutive interior here and here, these two angles. These two angles will be consecutive interior. And then these two angles within themselves will be consecutive interior. So we have two pairs of consecutive interior angles. Alternate exterior. Exterior we talked about, it's outside of the two lines. And alternate means they're on opposite sides of the transversal. So this angle here would be alternate exterior with this angle. And then this angle here would be alternate exterior to this angle up here. Those are alternate exterior angles. And then finally, we're going to talk about corresponding angles. When you have two lines and one transversal, you're going to have 4 pairs of corresponding angles. And what those angles are going to be is they'll be on the same side of the transversal, but you'll have one angle on the inside of the 2 lines and one angle on the outside. For example, angle 1 is on the outside of the 2 lines, and angle 5 is on the inside, but they're both on the same side of the transversal line, which I'm going to highlight in blue right here. Excuse me. Okay, so the angles that we have here, 1 and 8, what is their relationship? So take a minute to think about it. 1 and 8's relationship would be that they are alternate exterior angles. Why are they alternate? Opposite sides of the transversal line. And exterior, they're on the outside of the 2 lines. 2 and 7 are also alternate exterior angles. What type of angles do we have here? Well, they're both on the inside of the 2 lines, so they would be interior, and they're on opposite sides of the transversal. So 3 and 6 would be alternate interior angles, and so would 5 with 4. And that completes target 1.